So to get started with Ladybug for Blender, you can download it from the BlenderBIM add-on website and click on Get the Add-on. And if you scroll down, you'll find a link for SphereJoc, which is the parametric node-based visual programming interface for Blender, and Ladybug tools. If you click on the download button for SphereJoc, you'll be brought to their GitHub repository, which you can download their zip file from here. And if you click the download button under Ladybug Tools, you'll also get a zip file. Then back in Blender, go to Edit, Preferences, and under the Add-ons tab, click Install on the top right. And once they're installed, just click the checkbox to enable them. Make sure you've enabled SphereJoc before you enable Ladybug, and then restart Blender. So once that's done, you can go and open up a fresh Blender and split your screen and change one of the panels to a new SphereJoc nodes. Then press the New button to create a new node tree. And you can create new nodes by pressing Shift-A, and you'll find all the Ladybug nodes under here. Now, there's a lot of these, so Alt-Spacebar, and on my computer is the hotkey to search. So if you press that, you can press something like, or you can type something like file path, and so that you can load in files. And we'll use the import EPW node here. And if you just go and browse to an EPW file, which you should have, you can link the two up here. By the way, you'll notice that my connections are curved. If you want that, you can go into Edit, Preferences, go into Themes, and then Node Editor, and change your noodle curving, and I've got mine set to 3. Now let's create a new SunPath node, and we'll hook up the location node to there. And we will also want to visualize the results. And in order to do that, you'll use an Ladybug out node. And some of these outputs contain geometric results which can be visualized. So some examples are the analemma. So if I connect that, you'll see that it's baked the results to my scene on the top right. The baking right now just proves that the output is there, and in the future, this will be changed. At the same time, you'll also find that the geometry has been converted into SphereJoc geometry. So if I open up a stethoscope, you can see an array of coordinates for the vertices and indices for edges and faces and so on. So if you wanted to and you didn't want to bake them, you could control click over there, and here you can see the unbaked geometry coming directly from SphereJoc. But for the moment, we're just going to be baking the geometry, but just be aware that at the moment that does clutter your scene quite a bit. Now it won't rebake unless you press the refresh button. So you'll notice that even though I change things here, it will not recreate the geometry until I explicitly press the button. So if I go and add some more of these, and we'll add a legend, a title, and there we go, and we press refresh. Now you can see I have the full compass added to my scene. If I wanted to, I can also add some data to this node. So let's say we want to visualize the dry bulb temperature. So I'll connect that to there. And we'll also need an analysis period. And these have various defaults set to them, which at the moment you can't tell, but they are the same as the grasshopper ones. So if we connect the hours of year to there, and then if we press refresh one more time, you'll see I have my color points showing up, as well as my legend. And if the color points don't show, you will need to install the Point Cloud Visualizer add-on, which you can get from here. And if you click on the GitHub link, this is the file that you'll need to install. So simply download this file and install it, save this to your hard drive and install it like you would any other add-on. And then from there, you can visit the Point Cloud Visualizer tab, and the colored points, you can adjust the size of the points, for example. As one more example, I'm going to delete this and do a small analysis of a plane, and we'll make that plane a little bit bigger. And we'll also create a little building, and I'll separate the two objects, one for my plane and one for the building. And we're going to do an analysis of sun hours on this plane and building. In order to read objects in from the scene, you can use the scene in nodes. So for example, I can use objects in, and I'll do two of them. One of these will pick up just the both of the objects, and one of these will only pick up the building, which will be creating shade. Now, when using the objects in node with Ladybug nodes, you're required to nest them one more time. And a good way of understanding what that means is if you see any other node, you'll notice that there's two levels of nesting before the data appears. And that is a convention which is used throughout SphereJoc to allow looping through various data. However, if I link objects to it, you'll notice it's only nested once. So we're going to be using a list join node inside here and pressing the wrap button to create that extra level of nesting. And you'll have to do this every time you want to use objects at the moment. In the future, we can probably streamline that a little bit. So now we'll link the one with both the objects into the geometry that we want to analyze, and the one with the single object of our building into the context node. We'll also need some vectors for the sun directions. And we'll also need a true node to be fed into the run. So we'll just put in our logic functions, and we'll change this to true and connect this here. Now in Grasshopper, you would set the grid size to be a number of sorts. So for example, you might send it to be 1 or 0.1 or whatever you're looking for. But that will actually be ignored in Blender at the moment, simply because in Blender there are very easy ways to subdivide. So you can subdivide it manually like so. So now I have a grid of 4, but you don't need to do that. You can also add a subdivision surface modifier. And if you don't want to modify the surface, if it's a hard surface, you can press simple here and just up this to whatever you feel comfortable with. So I'm going to set this to 4. And so once that's done, if I create a new LB out node, it won't actually start the calculation until I hook this up to an output node. So if I hook up the mesh to an output, you'll see the results. And once we press the refresh button, you'll see that we now have a colored set of results. If you want to visualize the colors with a bit more vibrancy, you can change it to flat, which will remove any shading. If I go and hook up the legend, that will make a little bit more sense. And unfortunately, right now, there's a little bit of cleanup to do. And if I press refresh one more time, we'll get the results that we're looking for.